All right, let's go ahead and talk about worksheet 28, our Unit 4 study guide. Really quick unit here, so we're going to have a quick test. Shouldn't be too bad. A lot of it's honestly just kind of the same thing, just done in a different way, right? It's all about slope, y-intercept, and writing a linear equation in slope-intercept form. So let's take a look at number 1. We've got a real-world situation here. Your pet iguana can eat 4 crickets per minute. Remember, whenever we see that per, we know that the number that we're talking about is going to be our unit rate. All right? So we're going to fill out the table and write an equation for the relationship between the number of crickets and the time it takes your iguana to eat them. So after 0 minutes, right, x represents our time. After 0 minutes, your pet iguana must have eaten 0 crickets, right? This is going to be a proportional relationship because we don't start out having already haven't already eaten any crickets. So right now the iguana's eaten 0 crickets before we start the timer. But after 1 minute, how many crickets can that iguana eat? Well, luckily for us, we know that this iguana, your pet iguana, can eat 4 crickets per minute. So after 1 minute, they'd be able to eat 4 crickets. The pencil does not look good with the reflection here, so let's just go ahead and do this. Boom. All right, 4 crickets in 1 minute. That's going to be 8 crickets in 2 minutes, right? And we can do that just by identifying what our change in y is here. And we can continue that on to fill out the rest of our boxes. We're just adding 4 each time. And up on the top, we're adding 1. So we can see that our slope here is going to be 4 over 1, change in y over the change in x. And that's just going to be 4. And we already knew that because we saw that they can eat 4 crickets per minute. Remember, whenever you see per, you know that that number right there is your unit rate, which in this case is our slope. And our y-intercept is just wherever x is equal to 0. So we look on our table for an x value of 0. We see it's right there. And we look at the number right underneath it. That's going to give us our b value of 0. So we can write the equation y equals 4x. Again, we're always going to be writing in the form y equals mx plus b, just like that. And here our b is 0, so we don't need to add it on to the end. Now, number 2 says we're going to have to find the slope and state whether or not this line is linear. So if we're able to find a constant change in y and a constant change in x, that means we can find our slope. Therefore, it is a linear or a straight line. But if we see that there's no constant change in y or there's no constant change in x, then it's not a linear equation. We cannot even find a slope. So let's go ahead and see here what our change in x is. We got plus 1, 3 to 5 is plus 2, and 5 to 6 is plus 1. Now before we just dismiss this, right, remember last week, before we just get rid of this and say, oh, it's nonlinear, let's make sure that we have a not constant change in y on the bottom. From 25 to 27, that's plus 2. From 27 to 28 is plus 1. From 28 to 32 is plus 4. And 32 to 34 is plus 2. So this one is really, really close to being a linear relationship, but it's not because of this change right here. If we were to set up our slope fractions, we would see that we'd have 2 over 1, 1 over 1, 4 over 2, and 2 over 1. Now these 3 fractions are all equivalent to each other, so those would work out. But again, because this one is different, it gives us a different slope when simplified. That's equal to 1. Those are all equal to 2. We know that we don't have a constant change here, so this is non-linear. Can't write an equation, cannot find a slope. Moving down to number 3. Number 3, we're looking at a graph here. Let's just go ahead and analyze some things about this graph right away. The first thing we want to do is fix our scale to make sure we know what each of these notches is. So we can see that 2 notches up the graph is 40, which means 1 notch would be halfway to 40. That's going to be 20. And now we know that each notch is going by 20. Here's 60, 100, 140, and 180. And I like to do that just to really get a better idea of what each of my notches on the graph is. We can do the same thing on the x-axis. 2 notches over is 10. Halfway to 10 would be 5. So we can go by 5s and fill in all the rest here. 25, 30, 35, and 40, and so on. So let's go ahead and find the slope of this line, the y-intercept, and then write the equation. So for the slope, we can just do a rise over run. Let's go ahead and go up here. We're going up 20, 40, right? We're not going up 2. We're going up by 40 from 100 to 140. And then we're going to go over from 20 to 30, which is 10. So our slope is going to be 40 over 10, which simplifies to 4. The y-intercept of the line is wherever this line crosses the y-axis. Looks like it's right there, not quite at 0, just up a little bit at 20. So we can write the equation y equals 4x plus 20. Nice and simple. Again, we're using y equals mx plus b for our form, always, when writing the equation here. But now we have to interpret the meaning of the slope and the y-intercept in this problem. Now, when we see that word interpret, that means we've got to explain using our words, right? So we're not looking for a number here. We're looking for an interpretation based on the situation of the problem. So I don't want you to write, oh, the y-intercept is where the line crosses the y-axis. We know that. Okay, we're not looking for the definition of slope and y-intercept. We're looking for the meaning of it in this problem specifically. So this problem, what's even going on? We know that there's a cleaning service, and this graph here represents how long it's going to take versus how much it's going to cost. So what do the slope and the y-intercept mean in this circumstance? Well, we see here that we start spending $20. Okay? So when time is 0, the total cost is $20. How can that be? If no time has elapsed, how has the cleaning service already charged you $20? Well, we can say that the cleaning service charges a $20 initial fee, or we could say even deposit. And that represents our B. And we can say they also charge how much money per minute. Well, that would be the interpretation of our slope. We did 40 over 10, right? 40 was dollars, 10 was minutes. So our 4 is going to be dollars per minute. So they charge $4 per minute to clean. So by interpreting the meaning of our slope and y-intercept, we're taking the numbers that we found and we're essentially explaining what those numbers mean. We're not explaining what the slope is as a definition or what the y-intercept is as a definition. We're also now going to have to find the total cost of the cleaning service after 60 minutes. And we can do that by plugging 60 into our equation. Now there's 2 spots to plug it in, x and y. How do I know which spot to plug it in? Well, look at the units. 60 is in minutes. Our y-axis here was dollars, but our x-axis was in minutes. So we're going to replace x with our 60. Right? So $4 per minute times 60 minutes would give us $240. Plus the $20 initial deposit gives you a grand total of $260 to clean for an hour. And we could even take this a step further and interpret that $20 initial fee as like a supply fee, right? You can get creative with it if you want. You don't have to be that specific, but you can come up with something that makes sense if you would like. It's up to you. As long as you don't define slope and y-intercept, we'll be good. You should be fine. All right, more word problems. Hooray. So, number 5, the temperature of your pool during the night is shown in the table below. Find the slope and the y-intercept. So, we've got time here, and I forgot to write in hours, and then temperatures in Fahrenheit. I forgot the units, but that's okay. So as the time goes on throughout the night, your temperature in the pool looks like it's going to be decreasing, right? So as we go ahead, 2 hours plus 2 plus 2 plus 2. Down here on the y, we're going -4 -4. So if we're going -4 to the right, we need to fill in this spot to the left. Let's do the opposite and add 4. So our slope here is going to be -4 over +2. That just simplifies to -2. And our b value is right there on the table, where x is equal to 0. The number right under it is our b. And we can write the equation y equals -2x plus 94, where -2 represents the degrees that the temperature drops, okay, every hour, represented by x. And then 94 is our initial temperature. So for every hour, we're going to decrease by 2, but we start or begin at our initial value of 94 degrees. That's where we started at 0 hours, right? Now number 6, instead of having a negative slope, now let's look at a positive slope. So after months of saving up, you finally get to buy a PS5 for $500. Now each game you want costs $50. Now I know PS5 games cost more than $50 usually on average, but for the sake of this problem, I wanted to make it easier, give it a nice round number like 50, and we'll keep it at that. So we're going to fill out the table and write the equation between the total cost, okay, the total cost, and the number of games bought, right? So you may look at this table and immediately think, oh, if I've bought 0 games, then I've spent $0. However, you don't buy any games until you buy the system or the console. So even though we've bought 0 games, the total cost of what we've spent is $500, right? You've already bought the PS5. So now each additional game that you buy is going to cost $50. So if you buy 1 game, you've already spent $500 plus the $50 for the game. So we get $550. And we could just keep moving that along. We get $600 and $650, just like that. Our M is going to be 50. Right, our change in x is just +1. Our b is going to be equal to 500, our initial value. And we can write y equals 50x plus 500. That's our equation for that one. So these equations, as we're going to see here in one of these next chapters, these equations work kind of like machines. Y represents the total cost, right? So this machine is saying the total cost of what you're going to spend on this new hobby is $50 times however many games you buy, because each game is $50, plus the $500 that you spent initially to get the PS5 in the first place. So you could plug in any number of games here for X, solve and find the total cost. Like we could say 10 video games, right? That'll be 10 times 50 is 500 plus 500, and that's $1,000 total for the PS5 plus 10 games to go along with it. All right, flipping over to the back side now. Ooh, and it should be okay. So now we're going to write the equation of the line that passes through the points 3, 2 and 6, 11. To do that, we're going to have to first find the slope. Let's label x1, y1, x2, y2. Let me write our slope formula up here just in case we forgot. All right, y2 minus y1 looks like 11 minus 2. x2 minus x1 looks like 6 minus 3. We get 9 over 3, which just simplifies to 3. Now to find our b, we're going to have to use our formula b equals y minus mx. And I'm going to take this first point here, 3, 2. b equals 2 minus 3 times 3. 2 minus 9 equals negative 7. And we can write the equation y equals 3x minus 7. So a little two-stepper there. You got to do the slope formula and then our formula for b. But it shouldn't be too bad. Now, luckily for us, this one, we just have to do this second step. It gives us a slope of 3, right? M is equal to 3. Our x is equal to negative 2, and our y is equal to 4, right? X comma y, always x comma y. We're going to use b equals y minus m times x and plug all those in. 4 minus 3 times negative 2 gives us 4 minus negative 6, which is just 10. We know that b is equal to 10, m is equal to 3, y equals 3x plus 10. Multiplied those to get negative 6. 2 minus signs form a plus. 4 plus 6 is 10. Number 9, not too bad. We're going to find m and b. Luckily for us, we're just looking with our eyes. We're not solving anything. Here our m is 3 and our b is 4. Now, I saw a lot of people really get confused with this on a couple of assessments that we had. Guys, it's this form right here. B equals y minus m times, no, sorry, I'm so sorry. It is not that form. I was looking at the wrong thing. Y equals mx plus b. That's our form always, where m is our slope and b is our y-intercept. So whatever number is in front of x, that's your m. Whatever number is alone on the end of your equation, that's your b. And if we see that it's being subtracted on the end, we know our b is negative. 3 over 4, right in front of x. Now over here, what number is right in front of x? Negative 2, well that's our m. What number is being added off to the end? 3, well hey, that's our b. All right, number 10, let's write an equation for a line with a slope of negative 5 and a y-intercept at 0, 3. Very simple. Whenever we see a 0 as our x value, just like we talked about in a table, it's the same thing. We know that the number that comes after is our b value. And this one gives us our m value of negative 5. So we can just go ahead and write the equation y equals negative 5x plus 3. Very simple. Whenever you see that 0 in front, again, that tells you that that number next to it is your b. Here's our m. Y equals 6 over 7x minus 10. All we're doing is plugging in. We're not solving. We're not multiplying, anything like that. We're just replacing the letter with the number. Now let's go down and get some graphing done here. We got to write the equation of this line below. I know the lines are a little hard to see on this paper, but we can count up 1, 2, 3. You know our y-intercept is right there at 3. Now let's figure out our slope. We're going to do rise over run, starting with the leftmost point and moving to the right. We're going to start right here, and we see that we're rising 1, 2, 3, 4 spaces downward. And typically when we rise downward, we're going to say that that's a -4. Then we're going to run over to the right 1, 2, 3, 4, 5 spaces to the right. So our rise is -4, our run is +5, our slope is -4 over 5. And we can write the equation y is equal to -4 over 5x plus 3. Now with number 13, we're going to graph here. We got 8, 4. We'll go starting at the origin. We're going to go over to 8 on the x-axis and then up to 4 on the y-axis. Make our dot right there. 0, -2 means we're going to start at the origin and go 0 spaces to the left to the right. But we're going to go -2 on the y-axis and make our point right there. You'll have a ruler for your test. Connect those 2 points into a line. Make sure it actually goes through the point, unlike mine right there. And now we got to do all this stuff. We got to find the slope and the y-intercept and the equation. Luckily for us, we were given the y-intercept, right? Here's our 0. That -2 is our b. And once again, let's do our rise over run. We're going up 1, 2, 3, 4, 5, 6 spaces up. And 1, 2, 3, 4, 5, 6, 7, 8 spaces over. Rise over run is 6 over 8. 6 is 2 times 3. 8 is 2 times 4. Cancel out the 2's. And we get a slope here of 3 over 4. From left to right, this line is sloping uphill, so we know it's got to be positive. And we can write our equation. Y equals 3 over 4x minus 2. See how everything is kind of the same thing? We ended up writing an equation or finding slope or finding our y-intercept for almost every single one of these problems. On the back side, we did write an equation for every single problem, except for the ones where the equation was given to us. So a lot of good work on this. If you have any questions, please let me know as soon as possible before we take our test so you can get it worked out, and you'll be good.